In this video lecture, we will learn about linear programming problems. Linear programming or linear optimization is a process which takes into consideration certain linear relationships to obtain the best possible solution to mathematical model. It is also denoted by LPP. Thus, an optimization problem may involve finding maximum profit, minimum cost, minimum use of resources, etc. A special but a very important class of optimization problem is linear programming problem. Constraints optimization problem have three major components: decision variables, objective functions, and constraints. The activity variables or the variables, or in other words we call it as a decision variables, are denoted by x1, x2, etc., xn, are all considered to be positive, and the objective functions is considered to be a linear function, which is to be either maximized or minimized, is denoted by the linear sum of these decision variables. And the constraints is always considered to be a linear form of inequations, which is either greater than or equal to or lesser than equal to. There are certain assumptions have been taken, such as the certainty. It is assumed that all the model's parameters must be known. And if they are random variable, then we will solve the problem using stochastic LP model. And the divisibility. The solution of the values of the decision variable are assumed to have either whole numbers or a mixed numbers. And the additivity, in which the value of the objective functions for the given values of decision variables and the total sum of the resources used must be equal to the sum of the contribution earned from each decision variables and the sum of the resources used by each decision variable respectively. And finally, the linearity. The all relationship in the LP model must be linear. So hence, this is the general model of the LPP. So here we can clearly see that the objective function is in the form of a linear function, while the constraints are linear inequalities. Now, these are the certain important terminologies to be known in an LPP. First is solution. The solution is a set of all variables which satisfy the constraints, and the feasible solutions are those solutions which are solution also which is non-negative. Infeasible solutions are those solutions which are not feasible solutions. And basic solutions, that is, if there are m simultaneous equations, in other words, if there are m constraints and n variables, and if number of variables are more than constraints, then a solution obtained by setting n minus m variables equal to the 0 and solving the remaining equation of m variable is called the basic solution. In other words, among m out of n variables will have a non-zero values, where the rest of the variables will have the zero values, and those non-zero values are known as the basic solution. And the basic feasible solution, a feasible solution to an LP problem, which is also a basic solution. And the basic feasible solutions are, there are two types, degenerate and non-degenerate. In the degenerate, the basic variables will also take the value 0. In non-degenerate, all of the basic variables are non-zero values. Optimal basic feasible solutions are those solutions which optimize the objective function. Also, it's a basic feasible solution. And the unbounded solution which increase or decrease the objective function indefinitely. There are several methods to solve an LPP model, and one of the basic method is a graphical solution. Graphical solution is mostly used when there are two decision variables. In this one, we determine the feasible solution space and determination of the optimal solution from among all the feasible points in the solution space. Let us take an example where Jack is an aspiring freshman of XYZ University. He realizes that all work and no play makes Jack a dull boy. As a result, Jack wants to apportion his available time about 10 hours a day between work and play. He estimates that the play is twice as much fun as work. He also wants to study at least as much as he plays. However, Jack realized that if he is going to get all his homework assignment done, he cannot play more than 4 hours a day. How should Jack allocate his time to maximize his pleasure from both work and play. X1 is the hours per day and X2 is the work hours per day. Since Jack is available, time is 10 hours, so hence X1 plus X2 should be lesser than 10. Since he wants to study at least as much as he's played, that's why X2 should be greater than or equal to X1. In other words, X1 minus X2 is lesser than or equal to 0. Since he wants to get all his homework done, he cannot play more than 4 hours, so that's why the X1 should not exceed 4 hours. He estimates that the playing is twice as much as fun, so hence his objective is to optimize the fun, that is, maximum of z is equal to x1 plus x2. Hence, the LPP can be stated as maximize z is equal to 2x1 plus x2 such that x1 plus x2 is lesser than 10, x1 minus x2 is lesser than 0, and x1 is lesser than 4, and x1 and x2 should be non-negative. Here is the graphical representation. So here are the straight lines which is formed by each inequation to the equation. So here the check out all the points of intersection, that is 0, 0, 0, 10, 4, 6 and 4, 4. And now the optimum values will always lies at the point of intersection of these constraint lines. So hence among 0, 0, 0, 10 and 4, 6 and 4, 4, the 4, 6 has got the maximum value, or in other words, it's optimized the value of z, which means he has to spend about 4 hours for the playing and 6 hours for the study.